Surprisingly, this topic can catch A-level math students off guard. I'm going to go through an example of rearranging formulae. Now, you may be thinking, rearranging formulae, that's GCSE. You'll see why in a minute. It's actually trickier than what you may think. So with this question, we have a curve and we have that dy by dx is equal to all of this here. So the question is to show that the x-coordinates of the stationary points satisfy this result here. Now we know that stationary points can be found when dy by dx equals 0. So firstly, the obvious step is just to make this thing there equal to 0. So therefore, just making this equal to 0 like that. Now, it's probably an obvious thing to do, but if we just add this to both sides to get this over this side of the equation, it's going to make things look a little bit neater. So we end up with something looking like this here. Now, the question is, if we just go back to the original question, notice how we're trying to get x equal to this. And yet with this result here, we've got two x's. Now, obviously, they're the same thing, of course, but we've got to decide which one we're trying to quote make the subject of the formula. Now, it's not really making the subject of the formula because this is an implicit formula. We've defined x implicitly because x is within the formula, but we've got to decide which one we're trying to isolate. That's really the question here, and it's not immediately obvious how to do that. Now, what I'm going to do, just look at the question here. Notice how we've got a 1 plus sine x plus 1 on the bottom. So we want to somehow try and factorize out a sine x plus 1 somewhere here. Let's times both sides by x plus 1, and let's just see what happens. So we get something like this. Now we can just obviously expand the brackets there and there. So we'll do that just now. So expanding our brackets, we get something like this. 0.5x sine x plus 1, 0.5 sine x plus 1 is equal to this. Now again, we're trying to somehow get a 1 plus sine x plus 1 somewhere involved, a factor of that, because we're going to have to divide by that somehow to get the answer that we need. So now looking at this, we've obviously got a 0.5x sine x plus 1 there, and we've got a minus 0.5x there. Now I want you to notice that if we add this to both sides, we can now factorize out an x to give us 0.5 sine x plus 1 plus 1. So again, I've just added this to both sides. Notice how we now get this. We can actually take this here away from both sides, so let's just quickly do that. So now we end up with this. Now, as I said before, we can factorize out a 0.5x, and then that's going to give us sine x plus 1 plus 1, as the factor says up there. So factorize out 0.5x, and we're going to have here sine x plus 1, and then plus 1 is equal to all of this here. So that gives us this denominator that we're looking for. So we now know that we're on the right track, because what we can now do is divide both sides by this, and at least we're going to create this denominator there. So let's do that. So now we end up with this. So again, this 1 plus sine x plus 1 is there. So we've created that. Let's just divide by 0.5. So times both sides by 2. So therefore, we end up with this here. Now, notice how this is not quite the answer we needed. So a lot of students now would get stuck because they would get this here. They get the denominator that we needed there. But now the problem is we need to get a minus 1 somehow. So the little trick you can use in a situation like this is, obviously you don't want to change this fraction, but the trick is that if you add 1 and then take away 1, you've now created this minus 1 here. And what you can do is you can say that that 1 is the same as 1 plus sine x plus 1 divided by 1 plus sine x plus 1. So again, I've just written out the formula from before. So as I said, the little trick that you can do with these questions, if you do need to get a minus 1 at the end, just do plus 1 minus 1. And then you're going to write the plus 1 like this. So 1 plus sine x plus 1 divided by 1 plus sine x plus 1. So exactly the same as this denominator there, to have your common denominator. So now you've got your common denominator of this 1 plus sine x plus 1. Sorry, it's hard to hold a phone up and write at the same time. And now you can just add the top together, the two tops. So 14 plus 1, that's 15. And then minus sine x plus 1 plus sine x plus 1, that's just 0. That just gives us 0. And then minus 1. And so we're left with our final answer, 15 over 1 plus sine x plus 1, and then minus 1. And that's our result there. So a bit tricky, and it does require a bit of a trick. Now, I do know that in an exam, it may be quite challenging to spot those little tricks and techniques. So what you can do instead, if you do get stuck, go to the answer and work backwards. You can do that too. So what I mean is that you start with the answer and then you do some algebra to work from the answer to here. Now you can try this yourself as a bit of homework, and it's probably going to end up easier than doing all these tricks and techniques here. Now unfortunately, when you're in an exam, you can't easily tell which method is going to be quicker. You just can't, because until you do the question, you'll never know which approach is quicker. Whether it's quicker to do the end first and work to the start, whether it's quicker to start with the start and go to the end. You're never going to tell, but sometimes it may actually be quicker to start with the end point and work backwards to that there. So it's really up to you. Depends how you feel in the exam. Depends how well you do with the specific question you have. But I do hope that's giving you a bit of guidance. If you've got any questions, just let me know.